out here. What percent of Rafael Nadal's first serves are between 100 and 110 miles per hour? What's X? The first serve speeds in miles per hour. The variable X has a normal distribution with mean and standard deviation. That was on this last example. The mean was 115 and standard deviation is 6. We're interested in what's between 100 and 110. So plan, draw a figure below showing the distribution with the area of interest shaded. So again, here's where I'm going to be super picky. I want to see your picture. So sketch a curve. What's our mean? 115. I'm interested in that between 110 and 100. I'm interested in this in here. I don't know exactly where those numbers go. I'm just kind of ballparking it. I could figure it out with my standard deviation, but I'm not going to. So here's my question. If I want to figure out what's the proportion in between those 2 points, can I just jump in and look up 100 and 110 on my table of z-scores? No, the z-scores don't go that high. So here's where I'm at. I have my real life values. I have my serve speeds. And I want to get down here and I want to figure out, well, what's the proportion? So in order to get from here to here, I need to standardize it. So I find my z-score, and then I can use my z-score to get my percentage, or my proportion. So for my z-score, we have x. If I start with my 100, your x minus your mean, divide by standard deviation, and standardize the one for 110 as well. Negative 2.5, yeah. And if z equals 110, minus your mean, divide by standard deviation, 0.83 on this one. My x value minus the mean divided by standard deviation for each of those. So here at 100, my z-score is negative 2.5, and with this one, my z-score is negative 0.83. So to figure out what's in the middle of those two, look up negative 2.5. Negative 2.50 is what it would be. So from here to the left, we have 0.0062. And from this z-score, negative 0.83 to the left, we have 0.2033. How do we find what's in the middle? Subtract. .1971. So draw your conclusion. What do we know? If this is 0.1971, that's about 20%. So we can say about 20% of first serves, or first serve speeds fall between 100 and 110 miles per hour. You can try the next one on your own, or I'll kind of talk you through it too. If you got it, go for it. Heights of 3-year-old females, according to cdc.gov, this is a very, very reliable website. It's your Center for Disease Control, I believe is what that is. Any .gov website is going to be super reliable. The heights of 3-year-old females are approximately normally distributed with mean of 94.5 centimeters and standard deviation of 4 centimeters. What is the third quartile of this distribution? So we're going to let x equal, what are we talking about? Heights, yep, of 3-year-old females. Got it. This variable has the normal distribution. It's n, and then it's what goes in your parentheses. So your mean and then your standard deviation. Yep, your 94.5 and then your 4. The third quartile is the value of 75% of the distribution to its left. So here's where I direct you over here again. If I'm telling you 75% and I want to know what's the height for the 75th percentile, I need to come through here and figure out, well, what's my z-score so that I can unstandardize it to figure out my height. So if we are trying to find 75%, you look in your table, what's the closest we can get to 75%? And again, that's one of the numbers inside your table. Where do we find 75% at? Yeah. 75% lies in here. That's as close as we can get. And it's actually closest to this one. So what's our z-score? 0.67 is your z-score there. So we come down here. I'm like here. My z-score is 0.67. So using table A, the closest table entry to 0.75 was this 0.7486. This corresponds to a z-score of 0.67. To unstandardize the following equation, we solve for x. So what is it? Your z-score equals that x value we're solving for minus your mean divided by standard deviation. So to get rid of this denominator, instead of dividing, we multiply both sides by 4. Good. Add your 94.5 over. Thanks. So our x value, 97.18 centimeters. Draw your conclusion. What's that tell us? What did we find? We found the third quartile. For the heights of 3-year-olds. Actually, it's 3-year-old females. Is 97.18 centimeters. Alright, let's keep moving. The new part today, assessing normality. How do we know if something is normal? First, we need to plot the data. And I'm going to have you do a couple questions like this. First, we always plot our data, and what we're going to typically be using is a histogram, because we want to know, does the data appear to be symmetrical to even start out? For the sake of these questions, the ones I give you, they're all going to be roughly symmetrical, just to give you a heads up. But we plot our data, we want to see, is it symmetrical? And then secondly, we check whether the data follow the 68, 95, 99.7 rule. We'll count how many observations fall within 1, 2, and 3 standard deviations of the mean. And then we'll see how closely do those percents fit the 68, 95, 99.7% targets. So first things first, we're going to cheat. We're going to put this data in our calculator. We're going to make a histogram, and then we're going to sketch it, rather than doing that all by hand. Oh, yeah. And so we are doing lots of calculator tricks today. If you go second plus 7 enter 2, that'll clear your memory, which... Second plus 7, enter 2. And then if you push the stat button and edit, stat and then edit, we'll enter our data in list 1. We have 12.9, 13.7, 14.1, 14.2, 14.5, 14.5, 14.6, 14.7, 15.1, 15.2, 15.3, 15.3, 15.3, 15.3, should have 4 of those, 15.5, 15.6, 15.6, 15.8, 16, 16, 16.2, 16.2, 16.3, 16.4, 16.5, 16.6, 16.6, 16.6, 16.8, 17, 17, 17.2, 17.4, 17.4, 17.9, 18.4. You should have 36 numbers. So let me ask you this. When you're saying you have 37, are you in the blank space?
Yes.
So if you arrow up, you're at 36? Okay. If you don't, run through real quick, see which number you're missing, and put it at the bottom, or delete an extra one out. Get your information entered, and then we're going to sketch your histogram. I'm going to do mine right here just because I have my calculator next to it. How do we label our y-axis here? This is always frequency. There's a C in there. Here, frequency. And what are we talking about? I didn't even read the question to you. The measurements listed below describe the usable capacity in cubic feet of a sample of 36 side-by-side refrigerators. So this is our usable capacity. How do we get our graph? I would go second mode and quit out of there. If you go second, y equals, that'll take you to your graphs, your stat plots. Number 1, push enter, turn it on, and let's do a histogram. So now if I go to my graph, I don't see anything. Remember what we do? We did enter the data. I turned my graph on. Zoom 9, zoom stat. Bam, look at that. But when we trace along here, are you really going to recreate that on your paper using those digits? If I push the trace button? Yeah. But do I want to scale my axis and count by those funky numbers? Not if I'm trying to trick Miss Rupe into thinking I did it by hand, right? So what do? We go to our window, and instead of counting by 0.91666, how about we just count by 1? And then we can look at our graph again and see what happens. Oh, it's off. It's off the chart. See, my 1 bar is missing. What do? Go back to my window. I want my Y max to maybe be, we can go big. How about 15? There it is. Now it looks a little more symmetrical. 13.9, 14.9. Make it on your paper. I don't remember how high we went. And what's my very max? How do I scale my y-axis? Up to 11. So if I go 2, 4, 6, 8, 10, 12. Here I have 2 in this bar. And in the next bar I have 6. And 11. And 2. So it looks symmetrical. We're like, okay, it appears to be normal, but how do we know for sure? So this is where we need to calculate, does our data fit the 68, 95, 99.7 rule? So we sketch your graph. What we need to do is we need to know what is our average and what is our standard deviation. I only have a sample of data, so I'm using X bar and I'm using my S sub X because those do a sample mean and sample standard deviation. So how do we get those numbers? If we quit, go second mode, second quit. Remember where we get that list of like 15 numbers? It's been a while. If you push stat, calculate, one variable statistics, and you can type in list 1. If you had multiple lists in there, we only have one list. Push enter again. Pulls up all this information. My X bar is 15.8. My standard deviation is 1.2. Notice they're really close. I'm not going to dock you if you use the wrong one because they're so close. 15.8 and 1.2. X bar is our average, 15.8. Standard deviation, 1.2. So I fill this in. Here's the visual for you. If you guys are like me, you like to see your visual. If I were to sketch my normal curve, we have 15.8 is in the middle, right? And then we count our standard deviation up and we count our standard deviation below. So I add 1.2 to that. That gives me 17. Add 1.2 again. Add 1.2 again. That goes 3 in that direction, and then I go 3 below. Subtract 1.2. So we could sketch the curve because what we need to do is we need to figure out if I take my average plus 1 standard deviation and my average minus 1 standard deviation, the first standard deviation goes from 14.6 to 17, right? My first standard deviation, if this is my mean in the middle, it goes from 14.6 to 17. This was my first standard deviation. So I'm like, how many values lie between 14.6 bless you and 17? So I come up here, I'm like, well, between 14.6 and 17, if I count those all up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 25. It's supposed to be a 25. So we have 25 out of 36. What percent of the data lies within the first standard deviation? What's 25 divided by 26? 69.4%. In this range, I have 25 out of the 36 numbers. So then I look at my second standard deviation. What's in between the second standard deviation? I'm from 13.4 to 18.2. So now I'm from 13.4 to 18.2. I have 34, all but the last 2 of my 36. 34 and 36, we divide those, you get 94.4%. And my third standard deviation, 12.2 to 19.4. So 12.2 to 19.4, that includes all of them. 36 out of the 36, that gives me 100%. Does my data fit the 68, 95, 99.7 rule? Am I close? It's pretty close. Let's do this. People ask me, they're like, well, Mr., what is close? I would say if you're within 2% of the 68, 95, 99.7, that'll just kind of be a baseline for us. So what do you observe? Our data appears to be approximately normal. It's not exactly, because it's not exactly 68, 95, 99.7, but approximately. Our data appears to be approximately normal. It's closely or fairly closely fits the 68, 95, 99.7% rule. Or if you told me it nearly fits the empirical rule, that works. Do we see it?